Welcome to the School of Life. Life is hard, but you have got to be harder. I'm Mrs. Collins, your life coach. Let's get started with Unit 3, Lesson 3, Transforming Function Equations. In this lesson, our essential question is how do we analyze the equations of functions? We're going to look at various types of equations in this lesson: quadratic, cubic, absolute value, as well as square root functions. What we're going to do is look at the general form of these equations, and we'll be able to identify the transformations that we expect to see on the graph. So, noting again, transformation rules. The different numbers in the general form of an equation will tell us what transformations we can expect to see on the graphs. So, our general form of these equations will be f of x equals a times the quantity of x minus h plus k. You'll see some various changes within at least this middle part here, the parentheses and then x minus h. Sometimes you'll see these parentheses will have an exponent at the end of a 2. That'll represent a quadratic function. If you see an exponent of a 3, that represents a cubic function. If you see our bars here, these are our absolute value bars. And so this type of equation will belong to the absolute value family. And if you see a square root, this belongs to the square root family, the square root function family. So do note that as we're looking at this general form of an equation, this middle part can vary. And based on what you see, you'll know which family you're in or which function family you're in. So 2 as an exponent, quadratic. Exponent of 3, you're in the cubics. The bars, absolute value. And then if you see the square root symbol, you are part of the square root family. So that's a square root function. Okay. Other things to note within this general form of an equation. This a, or the value that's being multiplied by this quantity, or the value that you may see in front of your x. This a has rules. The a stands for dilations and reflections. If your a is negative, that means that you have a reflection. Your function has been reflected. Okay. So for instance, if you have a parabola, it originally is like this if it's positive, but if you have a negative a value, it flips upside down. So a is for reflections. If the value of a is from 0 to 1, then that means that you had a vertical shrink. Which means that it made your function wider. If the value of a is more than 1, then that means that you have a vertical stretch. And it made your function narrower. Okay. The value that is inside of your parentheses that's either being added or subtracted to your x, this has rules, and we call it h. So your h rules. H shifts your function from left to right. If you see a plus h inside, then that means that you have a left shift. If you see a negative h inside, then that means that you had a right shift. So you shift it over to the right. At the very end of our general form of equation, we'll have a plus k. You'll find this number outside of your parentheses, if there were any parentheses. Okay, and so that k has rules. K moves your function up or down. If you see plus k at the end, then that means that your function moved up. If you see minus k at the end, that means that your function moved down. So all of these rules you will need to commit to memory or at least reference them on your notes when you're asked different questions. So again, there are A rules, H rules, and K rules. The A always comes again right in front of your set of parentheses, or the coefficient of your X. Your K will always come at the end outside of your parentheses, and your H will always be within your parentheses. So do again remember these rules. There's a couple of things to note. When you're looking at our different equations in our examples, sometimes your A, your H, or your K might go missing, or they may not be there. They may not be visible. Anytime you don't see an A value there, you should note that your default value is equal to a 1. So if you see no A, then your default value is a 1. So that means that you had no stretch, no shrink, and no reflection. So again, if your A is not here, and you just start off f of x equals your parentheses x minus some number, close parentheses, maybe a squared, plus k. If that A is not there, then note that it's just a 1, and realize that that means that there was no stretch, no shrink, and no reflection at that point. Okay, so that's one thing that you should remember with these problems. Second thing, if you see that there is no H or no K, then your default value is equal to 0. So if you don't see that there's a number that's being added or subtracted to your X inside of your parentheses, then that means that your H was simply a 0. If you don't see that there is no value at the end of your equation that's being added or subtracted, then that means that your K was simply a 0. So that's the second important thing that you should note for each of these problems. All right, so if we try some examples, identify the transformation of each equation. Noting that we have f of x equals x minus 3 squared plus 1. First off, thinking about the family that this is a part of, we have an exponent of a 2. So, because we have an exponent of a 2, this is a quadratic function. We're looking at a quadratic function. So number 1 represents a quadratic. The second thing that we can point out, let's look at those transformations. In front is where our A value would be. There is no number in front. So remember, if A is not visible, the default is that it's a 1. And since it's a 1, it really does not change anything. We don't have any stretches, no shrinks, no reflections. It's just the same as its parent function. Next, we'll look at our H. So our H is inside of the parentheses with our X, and we have a minus 3 for our H. Moving over to our H rules back at the top of our papers. This is our shifts left and right. We see a minus 3 as our H, so that's a minus H value. So this means that we had a shift right by 3. The next thing that we have at the end is our plus 1. That's our K value, and our K is a plus 1. So if we go to our K rules, the K shifts up and down. So in this case, we have a plus 1, so that's a plus K. So we have a shift up by 1. And those are our transformations for number 1. Let's try number 2. F of x equals 2 times x cubed minus 1. First, let's figure out which family we're in. We have an exponent of a 3, so we are a part of the cubic family. Cubic function family. It's a cubic. The next thing we're going to look at is our A. Our A comes in front of our x cubed in this case. So here we have our A value, and our A value is a 2. Now let's look at what we have about our A rules. A changes the dilations as well as reflections. If A is negative, it's reflected. Our A was 2, so it's not negative. If we have an A that's from 0 to 1, that's not our 2. If the value of A is more than 1, here we go. Since our A value was a 2, then that means that our graph will be narrow. So therefore, we have a narrow graph. It's narrower than its parent function. Inside of parentheses, we don't have a set of parentheses here. We just have our x. So therefore, the thing that's missing is our h. And so you should note that h equals 0 here. And so since h is equal to 0, we don't have any shifts left or right. That's all that means. No shifts left or right. Our k value is the last thing that we have. And our k is a -1. So since k is -1, here's our k rules. That means that we are going down by 1. So we have a shift down by 1. Shift down by 1. All right, next we have number 3. -1/2 times the square root of x minus 1. First off, identifying the family, we have a square root. This is a square root function. Out in front, we have our a value. So a is a -1/2. So let's look at our a rules. So first off, our a is a negative. So we have a reflection. Okay. Next, our a is a 1/2. So that's a value that's between 0 and 1. So this will be wider than the parent function. Next, under our square root symbol, we have our x minus 1. So here, this is our h value. So this -1 there, our h equals -1. Let's look at our h rules. H's shifts left and right. We have a -1 for our h, so we have a right shift of 1. Okay, and then notice at the end of our equation, we don't have our k value, so therefore our k is simply a 0 since it's not there. So that means that we didn't shift up and we didn't shift down. There's no change for k. So if we're using those same transformation rules and trying a few more problems, examples, we have number 4. F of x is equal to negative absolute value of x plus 2. First, identifying your a. So our a here is a negative. We don't see the number there. Default is that it's a 1. So it's a -1. Okay. This is an absolute value function. A is -1. So that means that we're going to have a reflection. And since it's a 1, no other dilations in this case. It's not going to be wider or narrower. Okay. Inside of our absolute value bracket, we have a +2. So remember that inside, that's our h. So h equals a +2. So looking at our h rules, we're going to shift left by 2. And then lastly, at the end, we have no k value, so there's no shifts up or down. These are our only answers here. Number 5. Number 5, starting off in the front, we have an a value of 2/3. So that a value of 2/3, that is an a that's from 0 to 1. So this will be wider. Inside of our square root, We have a minus 1, so that's an h equals negative 1. So our h rules, if we see a minus h, that's a shift right by 1. And at the end, we have a plus 3. So that's a k value equals plus 3. So then therefore, we have our k rules, that's a shift up. So shift up by 3. Last thing we did do for this problem is identify which function family it belongs to. In this case, you have a square root. This belongs to the square root function family. All right, so if we look at number 6, we start off with f of x equals negative 2 times the quantity of x plus 4 squared minus 5. Our squared here tells us that this is a quadratic. So therefore, we're in the quadratic function family. The next thing, let's look at our a value. Our a equals a negative 2. Well, because it's negative, that means we'll have a reflection. And because it's a 2, so it's if the value of a is more than 1, then it's going to be narrower. Okay. Next, we move on to our h, which is being added or subtracted to our x. In this case, it's added. So our h rules, if we see a plus h, this is a shift left. So we have a shift left by 4. And I'll write that down up here, h equals 4. And then lastly, we have a k value of negative 5. And our k rules, if we see a negative k, then we're going down. So this is a shift down by 5. So at this point, hopefully you're able to use each of the rules in order to figure out whether or not you have shifts left, right, up, down, if you have a reflection, if it's wider or narrower, as well as you're able to figure out which function family each of these equations belong to. So what you're going to do is pause your video and try numbers 7, 8, and 9. Please give us all of the details for the equations you see. All right, and here are your answers for 7, 8, and 9. Please make sure that you check your work. If you need to go back and look at your A rules, H rules, and K rules, then go ahead and do so. Make adjustments as necessary. So with the last part of the lesson, we are going to write equations with the given transformations. So number 1 says, write the equation of the transformations of f of x equals x squared. So that's our parent function for quadratics that are right 5, down 7, and has a reflection. So when we're thinking about right by 5, right and left shifts are controlled by our h value. And so since we have a right by 5, our h, we're going to see a negative 5 for our h. We have a down 7. So going up and down is controlled by our k. And so if we have a down 7, we're going to have a negative 7 as our k value. So our k is going to be a negative 7. And then we have a reflection. So that means that our a value is going to be a negative number. So our a equals a negative. Put it all together, we're going to have f of x equals, we had a negative a value, so a negative out in front, times the quantity of x. Our h is a negative 5, so minus 5, close. This was a quadratic, so squared. And then our k at the end is a negative 7 because we had that shift down of 7. And that would be our equation for this problem. Let's try number 2. Write the equation of the transformations of f of x equals x cubed that has a vertical stretch of 2, up 1, and left 4. So vertical stretch, that has to do with our a value. Our up 1 has to do with our k value. And our left 4 has to do with our h. So let's go ahead and begin writing the equation. F of x equals, we're going to have, of course, our x, and we'll have our cubed. That a being a stretch of 2, a comes in the front, so 2 in the front. We have up 1, k goes at the end, and up 1 means that we're going to add 1. And then our left 4 means that we are going to have a plus 4 inside, because whenever we have a plus h, that means that we've moved left, so plus 4. All right, for the next one, write the equation of the transformations of f of x equals the square root of x minus 3 plus 4, that is down 9. So we only have one transformation this time, down 9. So moving up and down, that's controlled by our k. And here is our k in our problem. So since we are moving down 9, right now we're at a 4. So we're at 4, positive 4. Moving down 9 means that we're going to subtract 9. So minus 9. And let's see where that lands us. A positive 4 minus 9 is equal to a negative 5. So our new k value will be a negative 5. Everything else stays the same because we had no other shifts or no other transformations. So f of x equals the square root of x minus 3. Outside, we'll have that minus 5. And that's our answer. All right, number 4. Write the equation of the transformations of f of x equals the absolute value of x plus 2. That is left 2. So left 2, that controls our h. So our h is a plus 2. And then down 7. Down 7 is our k, and so we're going to be subtracting 7. So subtracting 7. Okay. Notice that we already had a k there, so don't go and write that negative 7 just yet. We have something to do with it first. So f of x equals the absolute value of x. There was no original h in here other than 0. So therefore, we can immediately just go ahead and add in that 2 for our h. So f of x equals the absolute value of x. It's going to be a plus 2 here. And then the last part, the k, is very important. The original k value is a 2. We are going to be moving down 7. So then we're taking the 2 that we have here. Moving down 7 means subtract 7. And we're going to end with a negative 5. So negative 5 is going to be our k value. So k equals negative 5. So minus 5. You try the next one. Write the equation of the transformations of f of x equals the absolute value of x that are left 4, down 2, and has a vertical stretch of 3. And here's your answer. F of x equals 3 times the quantity of x plus 4 minus 2. We know this because if we're moving left 4, then our h is plus 4. Down 2, our k is negative 2. The vertical stretch of 3 meant that we have an a value of a 3. Number 6. Try it on your own. All right, with number 6, we have our original equation, and we have transformations right 7 and down 2. So the right 7 will give us an h of a negative 7. The down 2 will give us an k of a negative 2. However, we already had an h and a k in our problem. So in this case, our h was a -1 originally. Since moving right by 7 will cause it to change by a -7, we'll have a -1, subtract 7. This is going to give us a -8. So -8 is our h. And for our k, we originally had a 3, but we are moving down 2, so we're going to subtract 2. So it was a 3, subtract 2. This is going to give us a 1. So our k is actually a 1. So in our equation, we're going to have f of x equals x, our h is in -8, minus 8, close parentheses, this was squared. And then at the end, our k will be a +1. And that's all for this lesson.